The first quantum number is called a principal quantum number, and which is designated by the small letter n, and this explains the main energy level actually. Sorry, what we have mentioned. It explains two things. One is the size and energy of an orbit or shell. Remember, even if we have just abolished the Bohr concept of orbit. Okay, there is no Bohr concept of orbit. That means there is no circular orbit. But for the easy reference, still what you can do is you can think about there are certain areas. Actually, these are the areas where the electron can be found. And for the easiness, what we can do is we can assume there is a circular thing. Okay, that's actually wrong. Okay, so anyhow, the principal quantum number describes about the size and energy of a shell or orbit. So as the n value increases, what you can say is the size increases. Similarly, with the n value, you can calculate the energy also. There is an equation, and based on the equation, you can calculate the energy also. And of course, it says about the distance from the nucleus also. Okay, all these explained by principal quantum number. Now, there is a relation between the principal quantum number and total number of electrons in an orbit, which is 2n square. N equal to 1, it is the first shell, K shell. So 2 into 1 square, 2 electrons. There are only 2 electrons are possible. N equal to 2, it is L shell, and 2 in the n value is 2 square, it is 8 electrons. Similarly, n equal to 3, 18, n equal to 4, 32, etc. electrons are possible. Now the next one is azimuthal quantum number, is denoted by the letter small letter L. Now each main energy level is divided into certain sub-energy level, and L defines the sub-energy level. Suppose L equal to 0, it is S sub-level, L equal to 1, it is P sub-level, L equal to 2, D sub-level, and L equal to 3, it is F sub-level. It is called S because the actual name of the sub-level is short, P for principal, D for diffuse, F for fundamental. And these are the respective number of electrons possible in each orbit. Now, see how many sub-level each main level can have. Each main level can have 0 to n minus 1 L value. L value means it is a sub-level. For example, suppose you take the first main energy level. It is n value equal to 1. If you substitute it here, only 0 is possible. 0 to n minus 1. So here the value is 1, 1 minus 1, 0. So only one sub-level is possible, which is 1s. So for the first main energy level, only one sub-level is 1s. For the second main energy level, 2 is equal to here, 2 minus 1. So L equal to 0 to n minus 1. So 0 and 1. 0 and 1 means it is 2s and 2. And for the third main energy level, we can have 3s, 3p and 3d, fourth one, 4s, 4p, 4d and 4f, etc. So these are the main energy level possible for, sub-energy level possible for each main energy level. Now we discuss about the magnetic quantum number. It explains the effect of an orbital in a magnetic field. See, remember your Zeeman effect. What was Zeeman effect? If you placed your main energy level or an orbital or in an energy level in an applied magnetic field, it will split. It will divide into different sub-energy levels. So that we discussed whenever we set up Zeeman effect. So that can be explained with the help of magnetic quantum number. That means an orbital will split into some more energy level in the presence of magnetic field. Okay, so that is explained by what is called magnetic quantum number. That is the orientation of an orbital in space. Clear? If you apply a magnetic field, it will split and will orient in space. Okay, clear? Now, how many m value each sub-level can have? Here lambda is by mistake given, it is L, that is the azimuthal quantum number only. So each main level can have see m equal to minus L through 0 to plus L value. Minus L through 0 to plus L value. That means if L equal to, for the first one, for L equal to 0, that is the S orbital, so we have the L value of 0, so only one value, there is one degenerate orbital. For L equal to 1, it is P sublevel, put here the L value as 1, so minus 1, 0 and plus 1. So minus 1, 0 and plus 1, so there are 3 degenerate orbitals are possible. For L equal to 2, it is minus 2, minus 1 up to plus 2. So 5 degenerate orbitals are possible. L equal to 3, of those 7. Minus 3 to plus 3. 7 orbitals are possible. Now we discuss about the spin quantum number. An electron can have two types of spin, it is upspin and downspin, or clockwise and anti-clockwise. So you can see this is equal to plus half for upspin. Clockwise, what is given wrongly, this is equal to plus half for clockwise, is equal to minus half for anti-clockwise. So that is spin quantum number. Now next we have to discuss about the shape of atomic orbitals. So we know S orbital spherical symmetry, P orbital dumbbell shaped, A orbital flower, leaf or double dumbbell, F orbital double flower. We'll discuss each other. S orbital is very familiar, it is spherical in shape. Now this is the shape of the P orbital. So we have Px, Py and Pz. So if it is oriented along the z axis, it is called Pz. If it is oriented along the y axis, it is called Py. Along the x axis, then you have to call it as Px. And they have m value as minus 1, 0 and plus 1. Okay. So any of this one is minus 1. So this is the concept of the magnetic quantum number. So there are three orbitals. They are actually degenerate. They are degenerate means unseen energy. And if you apply a magnetic field over here, what happens is these three degenerate orbitals will split. They will split and they will orient in space in different direction. And one will orient along the y-axis, it is called Py. Along the x, it is called Px. Along the z, it is called Pz. That's all. Here, this is what is the magnetic quantum number says. Now, similarly, this is the geometry of the d orbitals. We have px square minus y square, that is the four lobes are oriented along the x-axis and y-axis, and it is called, you can see that they are oriented along the axis. This is axis and this axis, then it is called dx square minus y square. This is pz square. You have two dumbbell along the two lobes along the z-axis, and a circle surrounding this one. That is the shape of pz square. Then you have dx and dyz and dxy. They are along the plane. Here is axis, here is axis, and these lobes are along the plane. Dxy plane, then it is called dxy orbital. Dyz plane, then it is called dyz orbital. It is much more clear here. This is your axis, this also is axis. This is y-axis and this is z-axis. So the planes are there, and you can see the lobes are on the planes. These are the planes. On the plane, yz plane, you have the orbital. That's why it is called the yz orbital. Similarly, the zx orbital. This is the shape of the orbital. They can have m values like this. So these are the shapes of orbitals. There are 7 orbitals. Okay. So with that, the discussion about the quantum numbers and shape of orbitals is all.